All right, guys, chapter 4. First part, we're going to talk about exponential and logarithmic functions. Second part, like 4, 3, 4, 4, 4, 5, we're going to talk about solving. You will need a calculator for chapter 4. A little scientific calculator like this is perfectly fine. No graphing, because you guys aren't going to graph. But, I mean, Target, Walmart, Amazon, $15 scientific calculator is all you need. Do not go out and buy a $150 calculator or anything like that. Okay, but you are going to have one. I would not suggest borrowing one from your friend the day of a test or a quiz, because if you don't know how to use it, I'm not going to help you use it on your test or quiz. But for some of this stuff, if you don't have a calculator, you won't be able to do it. So we're going to talk today about exponential functions. An exponential function looks like this. All right, this is written in terms of f of x. It's in function notation. F of x equals a would be the base. This is called the base. It's going to be a number. And then your exponent is the variable. That's where you get the exponential function from, because the exponent is a variable. This is your function, guys, right here. Whoops, I meant to highlight it. This is your function right here. So if you have something at the end that's adding or subtracting to it, that's your vertical shift up and down, just like normal. If you have a negative out in front, that would be a reflection, just like normal. If you have something added or subtracted in the exponent, that's going to move it right and left because it's with the x, just like normal. So on your web assignment, it asks you to pick the graph. You can plug in numbers for x and find y and plot the points. Or you can look at the different transformations and figure out which graph which. All right, these are just some examples of some exponentials. The big number, the big 2, the big 3, the big 10, those are called bases. And then your exponent is the variable. Here's where you're going to need a calculator when you have to evaluate. If they give you this function, f of x equals 3 to the x power, and they want you to find, letter A says f of 5. What do they want you to do with 5? Plug it in for x, okay? So you have 3 to the 5th power. Most calculators, guys, you have a 3, and then you're going to use what's called the caret button. It looks like the top of an arrow. That means raise 2, and then you have the 5th power. So in your calculator, if you hit 3 to the 5th power, you get 243. All right, there's not much partial credit I can give you on something like this. You need to know how to use a calculator. For letter B, if you notice B, you're plugging in a fraction. So this would be 3 to the negative 2/3. The way that you need to do this in your calculator is 3, you hit the caret button. Then you have negative. Negative is not the same as a minus sign. Negative is a little smaller. And then you have 2. Sometimes you have to hit the divided by button. Sometimes you have to hit the fraction button, whichever calculator you have. But make sure you put your fraction in parentheses. So this is 3 to the negative 2/3 power. And I get 0.48075. Exponential functions, guys, I'll say this a lot. They get big in a hurry or they get small in a hurry, because when you raise something to a power, if you're raising it to a whole number, it gets big fast. And if you're raising it to a fraction or a negative, it gets small fast. It's not a constant rate of change. Letter C is asking you to use 3 to the pi. What is pi? 3.14. So think about this. If it's about 3, right? So if you raise 3 to the 3rd power, it's 27. So in your calculator, if you hit 3, you hit the caret button and pi, you guys get 31.54. All right, that should make sense. 3 to the 3rd power is 27, so 3 to the pi power is a little bit more than 27 because the number is a little bit bigger. And then D is telling you to plug in the square root of 2. So you have 3, you hit the caret button, and then the square root of 2. You might need to put it in parentheses. Some calculators do it for you, some don't. But if I have 3 to the square root of 2 power, I got what? 4.72829. Now, it's important, guys, I'm telling you, you have to know how to use your own calculator. You have to know how to use the calculator that you bring to class. So I would bring one every day and ask questions. Go. All right, we're going to graph exponentials quickly. You guys are going to do a lot of graphing, but in order to graph, you just use a table of values. Plug in stuff for x, figure out what y is. So I have these two functions. All right, I have a. I'm going to do a here. F of x equals 3 to the x. And over here, we have g of x equals 1/3 to the x. So we're going to make a table of values, and we're going to draw a quick little picture for both. So x and y, I'm just going to do -2, -1, 0, 1, and 2. So if I plug in my calculator, 3 to the -2 power, I get 0.111. 3 to the -1 power, I get 0.333. What's 3 to the 0 power? 1. What's 3 to the first power? 3. And what's 3 to the second power? 9. So if you were going to make a quick little picture of this, right, here's 1, 2, here's -1, 2. All right, so at -2, you're at 0.111. It's like right there. At -1, you're at 0.333. At 0, 1, and then 1, you're at 3, and then 2, you're at 9. Do you guys notice how it starts off slow, and then it got bigger in a hurry? Your domain for all your exponential functions is going to be -infinity to +infinity. You can plug in any x's you want. You'll get out a y value. So over here, we're going to do the same thing. I'm going to use -2, -1, 0, 1, and 2. So if I plug in, I have -1/3, not negative. If I have 1/3, so 1 divided by 3, and I raise that to the -2 power, I get 9. So 1 divided by 3, I raise it to the -1 power, I get 3. What's 1/3 to the 0 power? God bless you. 1. 1/3 to the first power is 1/3, or 0.33. And then if I raise 1/3 to the second power, it's 1/9, which is the same as 0.111. What do you guys notice about these numbers? It's reversed. Right? 1, 2, 3, 4, 5, 6, 7, 8, 9. So at -2, 9, -1, 3, 0, 1, and then like this. So look at the picture of this graph. Again, this is -infinity to +infinity for your domain. Look at this. Look at these two graphs. Compare them. If I read them from left to right, what's the one on the left doing from left to right? Is it going up or going down? It's going up. It's a growth. This is increasing. What is the one on the right doing? Decreasing. This is a decay. You can tell by looking at a function if it's a growth or a decay by looking at the base. If the base is bigger than 1, it's a growth. If the number is between 0 and 1, it's a decay. Yeah. Say it again. Yeah, that's what I'm saying. When you look at it left to right, you can see that it's growing. But algebraically, if your base is a number greater than 1, it's going to grow. If it's between 0 and 1, it's a decay. Now, if there's a negative in front of it, then it's going to reflect it, that sort of a thing. But you can tell by the bases what kind of a function it is. All right, this is just showing you the different color lines with the different bases. Where do you notice all of these parent functions cross at on the y-axis? At 1. Right? When there's nothing being added or subtracted to the x to move it left or right, or at the end to move it up or down, it's always going to go through 1. Oh, that's what we just said right here, because a to the 0 power is 1. All right, good. Same thing. We're good here. All right, now, this is what I just told you guys. This is a growth, because we read a graph from left to right. So if I look at this left to right, it's going upwards. This is where your a term is greater than 1. Your base is bigger than 1. Over here, this from left to right is going downwards. This is a decay. And that's where your base is between 0 and 1. It's not always a fraction. Could be a decimal. And just because you see a fraction doesn't mean that it's a decay. Because if I have 5/3, that's a fraction, yes? But is that bigger than 1? Yeah. So just because you see a fraction, don't just go, oh, it's a decay. Doesn't always work like that. All right, if you want to find the function, okay, here's our formula. What's f of x the fancy way of saying? Y. Did they give me a graph and then they gave me a point on the graph? Yes? So you can figure out what this function is. What number am I going to plug in for my y? 25, good. Equals a, what am I plugging in for x? 2. How would I solve this? I'm going to take the square root, good. So a equals, you guys would tell me plus or minus 5, right? Yeah. Now, why is it going to be positive 5 and not negative? Because it's going up. So your function would be f of x equals 5 to the x power. Now, same thing over here. The formula is f of x equals a to the x. Well, what did they give you for your y value? 1 over 8 equals a to the what? To the third. So now what would I do? Take the cube root. Okay, good. So my a would be, what guys, what times itself 3 times gives you 1? 1. What times itself 3 times gives you 8? 2. So that should make sense that this is 1/2 to the x power. Why would it make sense that my base in this letter B would be 1/2? Because it's decreasing. It's going down. It's a decay. Good. All right. All right. I just want to talk to you about this. We are not going to use viewing rectangles on a graphing calculator. That's not going to happen. But if you were to graph this function, f of x, 2 to the x, versus g of x, x squared. Okay, what do you notice about 2? My base here. Is it bigger than 1 or smaller than 1? Bigger than 1, right? What kind of a function is this going to be? There's no reflections or anything like that, so it's just going to be a what? A growth. It's going to start small and then get bigger. You guys could plug in values. 2 to the negative 2, 2 to the 0, 2 to the 4th, whatever. Over here, I know this is going to make what shape? What shape is x squared? This is a parabola, right? All I want to show you is those two things are not the same thing. Yes, they both have x's, and yes, they both have 2's, but they're in different spots. You can always figure out the shape of any graph by plugging in values. Plug in stuff for x and see what you get out for y. You can do that every time. That's fine. But when you have an exponential, your function is going to get bigger or smaller in a hurry. I'm going to say that a lot. The numbers get big quick. All right, this is a very important slide, this one and the next one. You guys will have questions on your quiz. You'll have a calculator, but you will not have this formula. You have to find compound interest. Compound interest is an exponential function. An exponential function has a variable where? In the exponent. Do you guys see 2 variables here in this exponent? All right, so this formula right here is for compound interest. Make sure you take a picture of it, whatever. Principal, the P, that's the amount that you start with. This is your starting amount. And we're talking about money. So when you round, how many decimal places should you have? You're talking about money. 2. T. T is going to be the number of years. Years. Always in years. R is your interest rate. They're going to tell you an interest rate, but it has to be a decimal. I'll explain like that in a second. And then N is the number or how the interest is compounded, okay? This is going to be a big thing for you guys to pay attention to. If I say the word yearly, how many times does something happen if it's yearly? Once. All right, what about if I say semi-annually? Pretty sure I spelled that wrong. How many times a year? Twice, okay? What about if I say quarterly? Quarterly is 4. What about if I say monthly? Good. Month, I can't spell today at all. Monthly is 12. What about if I say weekly? 52. There's 52 weeks in a year. And what if I say daily? 365. You guys need to know all of these. When you are given those words, what number does it represent? I can give one problem with all the same information, and you'll have 6 different ways I could ask one question. I can give one group of 6 of you one question and change one little piece of information, and everybody's answer will be different. So you have to know what those words mean. So let's go to the problem so you guys can look at this. All right? It says a sum of $1,000 is invested at an interest rate of 12%. Find the amount after 3 years. All right, so let's talk about the information they gave us. What is 1,000? What letter did they give me when they said, hey, you're starting off with 1,000? That's your P, okay? That's the amount, that's what you're starting off with. They gave me an interest rate. What is the interest rate they gave me? 12%. If you put 12% into that formula, you will not get the right answer. How do you change a percent to a decimal? Move the decimal place where? 2 places to the left. You have to use 0.12. What's the time that they told me to use? How many years? 3 years. Now, how the problem can change is how the interest is compounded. If it's compounded quarterly, what do I use for N? 4. If it's compounded monthly, what do I use for N? 12, all right? So let's do quarterly and monthly. Just see the difference. Won't be a huge difference, but it will be different. Again, you guys need to know this formula. It should be next to you as you're working on this. So it's P times 1 plus. What's inside the formula? Rate over. Look back at the formula, guys. R over N to the what? N times T. Now, majority of people don't have a problem memorizing this formula. They don't have a problem putting numbers in. The problem they have is using the calculator. So just pay attention, guys. Now, if I say quarterly, what is my N value for quarterly? 4. So when you go to write this down, your initial amount was 1,000. And then you have 1 plus. What was your interest rate? So 0.12 divided by what? 4. And then that's raised to the N times T. So it's raised to the 4 times what? Times 3. In your calculator, guys, you see how I put a parenthesis around this fraction? If you do not put a parenthesis around that fraction inside, you will not get your answer right. You can plug it in exactly how I have it written. You can say 1,000, parenthesis, 1 plus, parenthesis, 0.12, divided by 4, close your parenthesis, close a parenthesis, and then raise it. What is 4 times 3? 12. I'll show you how to do it backwards with that one.
You can do it?
Yep, I'll show you. Anybody do that work with me? 1,000, 425, and how much cents? 76, okay? Now, when you do these problems, you can always check to see if you're on the right track. We'll talk about that in a second. But now we're going to do the exact same problem, but we're just going to change how we compound the interest. Now we're going to compound the interest monthly. What does monthly mean? What number is monthly? 12, okay? So same thing. I start off with $1,000. I have 1 plus. This is going to be 0.12 divided by 12. And I'm going to raise it to the what? 12 times 3. All right, so if you have a regular scientific, you can just go left to right. If not, work inside out. Do it with me.
Okay.
I'm gonna walk you through it. Ready? So do 0.12 divided by 12.
0.01.
Okay, plus 1. Then raise that to the 12 times 36 power. The xy, you got it?
Yeah. 1.430.
And then times by 1,000.
1430.
Yeah, you're going to work from the inside out.
Yeah.
Yep. Okay, so if we go this way, guys, we're going to say 1,000 times 1 plus parenthesis 0.12 divided by 12, close parenthesis, and you're going to raise it to the 36th power. And you get how much? 1,430 and 77. All right, now look at these two numbers. Are they really far apart? No. When you compound interest monthly versus daily versus quarterly, it doesn't make that much of a difference. But what I want you guys to understand, and what I want you to notice, where did we start? How much money did we start off with? $1,000. And after it's been in this account for 3 years and compounded whatever, we got to $1,400. Everybody see that? All right, same thing over here. We started with 1,000. After compounded monthly for 3 years, whatever we got here. You guys will not start off with an amount of $1,000 and it's been in something for 4 years, compounded this way, and come out with like 5 billion. Okay? What I mean by that is when you put it in your calculator and you get something times e to the, you did something wrong, right? Your initial that you start off with to what you end up with should not be millions of dollars apart. If you did something wrong. Another thing I want to bring to your attention, if you have an interest rate of 4.35%, is that a decimal? No. It's not a decimal. It has decimal in it, but is it a decimal? No, that's a percentage. How would you change that to a decimal? This would go over twice. So your interest rate for this one will be 0.0435. A very common mistake that I see a lot is you don't change the interest rate into a decimal because you see a decimal point in it. And then when you plug it into your calculator, you get an error message or you get some like ridiculously huge number. And that's why, because you didn't change it. So what I want you guys to do tonight, I know I went through this quickly, but I want you guys to practice tonight. Tomorrow we're going to do 4.2, and then you'll have time in class to work on 4.1 WebAssign and ask questions. Friday in class, you'll be able to work on 4.2 WebAssign and ask questions. And then we'll review Monday, Tuesday for a quiz on Wednesday.
So when is the 4.1 WebAssign?
Friday.
Oh, I thought that was due tomorrow.
No, I changed it.